All right, here's free response number 2. Commercial airlines need to know the operating cost per hour of flight for each plane in their fleet. In a study of the relationship between operating cost per hour and the number of passenger seats, investigators computed the regression of operating cost per hour on the number of passenger seats. The 12 sample aircraft used in the study included planes with as few as 216 passenger seats and planes, not plans, with as many as 410 passenger seats. Operating cost per hour range between $3,600 and $7,800. Some computer output from a regression analysis of these data is shown below. Here is our information. Question A wants to know, what is the equation of the least squares regression line that describes the relationship between operating cost per hour and the number of passenger seats in the plane? To find any variables used in this equation. From the scoring guidelines, we would get this right here. And remember that the slope and the intercept come from here. This is going to be the slope, and that's the intercept. So you see them right in there. Slope is the value next to the x. And you have a couple different ways to write it. You can say predicted cost equals 1136 plus 14.673 times the number of passenger seats, or you can do y hat equals 1136 plus 14.673 times x, and simply define what x are. All right, part B. What is the value of the correlation coefficient for operating cost per hour and number of passenger seats? That's R. So correlation coefficient is R. And that comes from R squared in this problem because we're given R squared. And notice that the slope is positive, so it's going to stay positive. So you'd say something like this. You just convert the 57% to a decimal, move the decimal place over, square root it, keep it positive since the slope is positive, and then make an interpretation. R is positive, 0.755, and then you'd say there's a moderate or strong positive linear relationship between operating cost per hour and number of passenger seats. I would say moderate or moderately strong in this case. You could also use the coefficient of determination and get credit. 57% of the variability in operating costs can be explained by the number of passenger seats. Either way is fine. All right, part C, suppose we want to describe the relationship between operating cost per hour and number of passenger seats in the plan for planes only in the range of 250 to 350 seats. Does the line shown in the scatter plot still provide the best description of the relationship for the data in this range? Why or why not? Well, if you kind of block off those, you're going to see that if you were to make a line of best fit just for those points, it'd look more like that. So that would be a negative relationship. So it's no. The equation of the least squares regression line is influenced by the 3 points in the upper right-hand corner and the 2 points down here in the lower left-hand corner. So if those were not there, you would have like a negative correlation. So the slope of the recalculated least squares regression line is going to be negative. So comment on the negative relationship here, and you'd be all right. All right, thank you.